Uh, my dear students, welcome to my video class. Today, let us discuss very important topics: geometrical isomerism. Geometrical isomerism. Okay. Geometrical isomerism is a kind of stereoisomerism. Stereoisomerism has been classified as geometrical isomerism, optical isomerism, and conformational isomerism. Here we are discussing about geometrical isomerism. What is the geometrical isomerism? It is uh, it is called a compound. It is same molecular formula, comma same structural formula, molecular formula, structural formula, but different orientation due to restricted rotation of carbon bond. Same molecular formula, same structural formula, but different orientation of groups due to restricted rotation of carbon bond. We have already said that carbon single bond has a rotation property. Because of that, orientation of the groups on the carbon is keep on changing. We have eclipsed, staggered, gauche, etc. But here carbon rotation has been restricted or prevented, and because of that, molecules have different geometrical orientation. That orientation resulted to geometrical isomerism. Now, the restricted rotation may be two kinds. First, due to double bond or due to ring. Double bond may be, we have a carbon double bond, carbon double bond nitrogen double bond nitrogen. These molecules normally shows geometrical isomerism. Here a ring cycloalkane shows the geometrical isomerism. Allenes shows, spiro compound shows, biphenyl compound shows. Therefore, geometrical isomerism could be shown by carbon double bonded molecule, carbon double bond nitrogen molecule, nitrogen double bond nitrogen molecule, cycloalkanes, allenes, pyro compounds, and biphenyls, if they can follow certain conditions. We will discuss that conditions of the geometrical isomerism. Okay. Conditions of geometrical isomerism. What are the conditions for showing geometrical isomerism? Conditions of geometrical isomerism. First condition, there shall be restricted rotation. There shall be restricted rotation. That is the first condition. Second condition, nothing but groups attached shall be different. Groups attached shall be different. That is a second condition. Okay. We will discuss one by one. First, geometrical isomerism of alkenes. First, GI of alkenes. Okay. An alkene can show geometrical isomerism if the groups attached to each carbon, to each double bonded carbon are different. Okay. That is, alkene should be like that. C double bond C, A, B, C, D. Second, it should be A, B, A, B. Okay, let me write like this. That's quite simple. Sorry. 1. A, B, C double bond C, D, E. Group attached are this carbon AB, group attached this carbon DE. Second case, A, B, C double bond C, AB. This is okay. Now third case, A, B, C double bond C, AD. Another one, C double bond C, A, B, D, B. Like that. What do you have to check? You have to check whether the two groups in this carbon different, okay. This carbon different, okay. Here two groups are different, these groups are different. Here these two groups are different, here these two groups are different. The groups here can be here, no problem. The groups present here can be here, no problem. Here also these two groups are different, these two groups are different. These two groups are different, these two groups are different. But suppose you have these type of examples. A C double bond, A B C double bond B B. This is cannot. Another one, C double bond C, B 2 A D, cannot. Another one, A2 C double bond C A2, cannot. What is the problem here? Here okay, but here not okay. Two groups are same. Here not okay, here okay. Here not okay, here not okay. Okay. I will come up with some examples. Fumaric acid, malic acid, malic C double bond C, H COOH. These two groups are different. Okay, this side okay. These two groups are also different. This side okay. These two groups are same, no problem. This is what we call cis. Here fumaric H COOH We are checking these two are different, these two are different. This is called trans. Nomenclature will be discussed in later. Malik says in the case of M, all legs are same side, therefore same groups are on same side. Just remember M, we write M like this. All groups are same side, therefore same groups are on same side. Malik. Okay, this is a type of geometrical isomerism shown by alkene. Therefore, I will write one more example, third example. Suppose you have a molecule like this. This is cannot show. Why? Because this is our carbon-carbon double bond. This side is hydrogen. This side is CH3. This side is H. This side is H. Therefore, these groups are same. Therefore, this is not geometrical isomerism. Another example, but this molecule shows because here hydrogen, here CH3, hydrogen CH. This group is different, this group is different. Another example, this is cannot show geometrical isomerism. Why? Because these groups are same. If you write perfectly condensed formula, you will get like this. Okay, this side is not okay. Similarly, 6. Do not show geometrical isomerism. But 7, I tell you an example. This is shows geometrical isomerism because this group is CH3, CH2. This group is hydrogen. This group also CH2, CH3. This group is hydrogen. Therefore, groups are different this side, groups are different this side. Therefore, it also shows geometrical isomerism. Okay, you can make the more examples. You can make the more examples. No worry about it. Okay. Now, next. Carbon. Second is imines. That is carbon double bond nitrogen. Hydrogen. We already know that this nitrogen is carrying a lone pair. Here lone pair act as pseudo atom. Therefore, this side is always okay because this will be like this. Hydrogen this side, lone pair. You have to write hydrogen always like this because lone pair will be in this side. Here a carbon. You imagine lone pair as an atom. Therefore, this side is always okay because here lone pair, here hydrogen. Now, to show the geometrical isomerism, the groups attached on carbon shall be different. That is, A should not be equal to B. Let us have some example. CH3, CH double bond NH. Very, very beautiful example. Because C double bond N, this H here already contain a lone pair. Now here one group is H, another group is CH3. Therefore, it shows the geometrical isomerism. Okay. I write another example, but this molecule, NH, do not show because this is a carbon, all sides are equal. Okay, you imagine, suppose you divide, this is, if this half is A, this also half is also A, therefore it cannot show geometrical isomerism. Similarly, suppose you have a C double bond NH, This is also do not share because these two groups are same. Therefore, this is all about the geometrical isomerism of imides. Another one, third is oximes. Oximes. What is oxime? C double bond N OH. As I have already said, this nitrogen containing a lone pair, it's like this. The only condition is that the groups here should be, A should be different with B. A should be A not equal to B. That's all. We have write some examples. CH3 CHNOH. Example. Another example, CH3 CH2 CH3 N double bond NOH. This is also shows geometrical isomerism. Another one, very beautiful example. Look at here. NOH. I just make a CH3 here. This shows geometrical isomerism, students, because this is a carbon. If you divide this A, this should be B. Okay, this is shows geometrical isomerism. Another example, CH3 C benzene ring NOH. This is also shows geometrical isomerism. In the case of oximes and imines, you have to check if whether the group attached to carbon are different or not. That's only you have to check. Okay, this is all about imines. No problem. Now, another one, the fourth one, N double bond N always shows geometrical isomerism. Always shows geometrical. Why? Because I already said you, each nitrogen has a lone pair. This also lone pair. Therefore, this group will be whatever the groups. If A here, but these are different. Therefore, all azo compounds like this shows geometrical isomerism. No problem about it. Now we can go to cycloalkanes. Geometrical isomerism of cycloalkanes. These are the cycloalkanes. Okay. It will show the geometrical isomerism if two carbon atoms containing at least two carbon atoms have different groups. If at least two carbon atoms have different groups. What is the meaning? Let us take this CH2, CH. This is our. Suppose you take at least two carbon. Here you remove one hydrogen and put CH3. Here one hydrogen. Okay. That is CH3. Here also you remove one hydrogen and put the CH3. Now it shows the geometrical isomerism. At least two. Therefore, this and this shows geometrical isomerism. This and this shows geometrical isomerism. This and this shows geometrical isomerism. At least two. Okay. Therefore, cycloalkane will show the geometrical isomerism if at least two carbon atoms have different groups. Okay. That is, I said to you, if you simply write like this, this is nothing but a CH2, 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 CH2. At least two. Suppose you take this one and put a CH3 here. You put any this and put a CH2, CH3. Therefore, these two carbon have different groups. Therefore, it can show the geometrical isomerism. Very simple. Okay. Therefore, all these compounds shows the geometrical isomerism. Now, spiro compounds. Spiro compounds. Spiro. We will discuss the spiro in detail. Spiro means this type of rings. Spirocon. Geometrical isomerism, if number of rings are odd, that is 3, 5, 7, etc. It shows optical isomerism if number of rings even, that is 2, 4, 6, etc. Not only that, here one more condition, groups attached must be different. Suppose you take a 3 spiral ring like this. Okay. Here you have an hydrogen. Here you suppose you have a Br. Another one is hydrogen. Student, remember another one is. Here also you have Br. Another one is hydrogen. Therefore, it shows the geometrical isomerism. But I just write like this. Here CH3, here Br, here CH3, here CH3. It cannot show. No geometrical isomerism. Why? Because this side is okay, this side is wrong. This side failed. This side okay, this side failed. Because the groups should be different. If no groups, okay, here what shall be the group? Again it is failed because here hydrogen. Okay, remember that point. That's about the geometrical isomerism of spirines. Now allenes. Allenes. Allenes nothing but a cumulative double bond. That is like that. Here also odd number allene geometrical isomerism, even number allene optical isomerism. Here one more condition, groups must be different. That is C double bond, C. Here you have CH3, H, CH3, H, geometrical isomerism. Okay. Optical isomerism will be discussed in next videos. Don't worry about it. Therefore, it shows the geometrical isomerism. Another one, C double bond, C, CH3, BrCl. No, because this side failed. Therefore, no geometrical isomerism. For geometrical isomerism, you have to check the both sides and ensure that the groups attached are different. That's only, very simple. Okay, this is all about the geometrical isomerism. Nomenclature of geometrical isomerism is discussed next video. Thank you.